Good morning, ladies and gentlemen. I would like to welcome you to my presentation. I want to talk about the project to migrate a business-critical application from DB2 to EDB. I will give you an idea how such a project can be done, depending on the given architecture. The content, first, a short introduction of the company and about me. Chapter 2, the situation when we started the project, the scope of the project, and the decisions that we take. Third chapter, the technology, short introduction, how we build it, how we automated it, and the technology behind it. Chapter 4 is the current status, the lessons learned from the project, and the conclusion to the project. Chapter 5 is only on the slides. The time slot for the lesson is too short to have this chapter in this session. This chapter 5 has additional information and a reference for the technical details. So it will be a good starting point. You have parameters there, you have some configuration files there that you can use to start a Postgres or EnterpriseDB database in that manner that we have used it. The introduction. My company is named BG Phoenix. It has around 500 employees, therefore 250 in the IT and 14 locations in Germany. The main operation is in Munich, and that is where my office is. We are the service provider for the German social accident insurance, and we manage over 8,500 IT users with more than 21,000 end devices. End devices, the full range, tablets, mobiles, virtual desktops via Citrix, FAT clients, and so on. We as a full service provider develop and operate complete applications for our customers, including the complete infrastructure. About me, I'm head of platform databases at the moment. At the project time, I was also responsible for the content manager databases and the content manager systems. I have 15 years leadership experience for technology teams and about 25 years database experience and all kind of database systems, let's say relational databases, NoSQL, shared nothings, Hadoop, Greenplum, and so on. I had many technology projects and experience in various technologies like storage and so on. Since December 2017, I am at BG Phoenix, and it was also the start of the project. When you have further questions about me or about the company, about the slides, you can contact me via this email. The situation. We started in 2017. We had nearly 1,500 databases in operation. Thereof about 500 are DB2. Many databases are highly consolidated and complex to operate due to the license situation that we had. You can see the picture here down. We have on one VM up to 20 databases, and it makes it very complex to get downtimes, to get patches in. The mission critical systems have also high availability network built, and the complete infrastructure is built on VMware. One of the points was that we had really long setup times for systems deployment by many participating teams. So when we create a machine, there's a team involved for storage, for network, for Linux, for Active Directory, and so on. And it needs time to get a change to the loop of all these teams. Also, with these high consolidated machines, we had many weekend activities because of this license-driven architecture. The mission and the scope of the project. The decision was replacement of all IBM products and until end of 2019, and with these large parts of the core infrastructure. So the content management systems, my responsibility, about 500 DB2 databases, the backup system Tivoli TSM, and the databases from the size are from smaller than 100 gigabytes, so for the development systems, up to 2.5 terabytes compressed for the big ones, partly with high availability clusters built. Scope was also convert the databases from the current ISO character set to UTF-8. And the content management system, to give you a number, had about 1.5 billion documents in, and we had to replace it also. So we looked for replacement products for all the mission critical systems in our enterprise network. We want to achieve a reduction of the license dependencies to the best technical architecture for the company and not for the license. We want also replace all the application servers from WebSphere to JBoss, because WebSphere is also IBM. And at last, the monitoring system was also IBM. ETM must be replaced too. What we have done, so the analyze and the procedure for the database. First, we sit together and said, okay, what else do we want to achieve? So, and we come out with this list. We want an automatic deployment of server and database with all parts, not to do installation server by server and database by database. We want a simple license model, high throughput and stability, an open architecture for expansion to cloud and containers. And if possible, we want to have the backups to S3 storage. This would give us the possibility to move the long-term backups, for example, to cheaper storage or to a cloud solution. We started creating a matrix with all the necessary features. And the list is only an example. A high availability, partitioning, hints, our application is using hints, how the optimizer should treat some statements. We have point-in-time recovery, procedural ability is a very essential point. I'll come later to this. We want to have an easily accessible support, a future-proof product and support, and all this on Linux basis. And you see the sentence in red. Be careful, the devil is really in the details. For example, I said it, hints. A few databases cannot handle hints. When the application is using this, they are out. Compression is not too easy. When you are used to have DB2 or Oracle and use the compressed feature, this is different in some database dialogues and also different in Postgres and EDB. After market analysis, we have done the comparison of 16 database systems with 32 weighted criteria, and at the end, we took the decision to EDB. Why EDB? During the project phase, we have seen it's a fast and competent support. It meets our SLA demands. The security roadmap of the product fits our planning. The DB2 code is migratable. We have checked this with a POC. The Oracle databases are also migratable, so as a further option. All necessary tools are included without additional costs. So resource manager, high availability, standby system, await diagnostic, a tool for pooling, standby system that is open for read and such things, all included in the fee. And when you use other databases, you know a lot of these features have really extra costs in other database systems. For sure, it must be ASIC compliant because the application, the main application, is absolutely business critical. We have seen that we have application support for Postgres EnterpriseDB for all our necessary core applications. EDB is also open-minded for customer wishes, so to adding options, discuss features that you want to have in the code, and that's really good for us. And it's a sustainable and stable with good product roadmap, so the Postgres core is really long on the market. Oops. To the migration method. From DB2 to EDB, there is no direct link available. You have to do this manually. There's also no direct way to migrate the character set from ISO to UTF-8. And we use the tool for the migration. And the tool is doing the data type and the character conversion. We have done also analyze with our development, should we build the migrator by our development or should we use a tool? And we found a small tool that is able to do what we need. So what we have done, we splitted the big schemas and the tables from the DB2 to batches and automate them that all will finish to the same time. That's a lot of work to do, but it's possible and you can automate it with this tool. We started with the databases with the size of 4 terabyte. I said in the beginning 2.5 terabyte, but it was compressed. We have seen with UTF-8 and a completely different compression on EDB side on Linux. We ended up with about 4 terabyte. And so we started with the migration phase with about 2.5 days, around 72 hours for the migration. This was too long. And so at the end, we had 12 migration machines with 12 automated batches. And we ended up with around 10 hours conversion time, plus at the end statistics and index rebuild for 5 or 6 hours. The technology behind this. I want to talk about the technology that we use to automate the deployment and how we have implemented it. And we give you also a short introduction to the problems we had and the solutions and workarounds. The technology, again, agenda. So I have private cloud, EDB environment, the problems and solutions, and the future vision, and where we're currently working on. The private cloud environment, have a look on the picture on the right side. Most people believe it's a straight way from the start to the success, but in reality, it's more the picture on the right side. You have many curves in the project that you have to manage, but at the end, it will come to a good success. So as I said, it's all done in a private cloud, everything fully automated. The migration or the automation is completely based on VMware for realized methods, and with Puppet code, the automation is done. We developed as DBA the complete functionality with bash shell scripts, tested it, and then hand over it to the cloud automation team, and they implemented it in the Puppet code. The machines that we built from RAM is about from starting at 8 up to 128 gigabyte, from the vCPUs from 2 to 12 CPUs. And you can see a wide range of CPU and RAM split. And so it was absolutely necessary to have on-the-fly calculation with defined formula for the essential parameters. So when we add the parameters in the slide, a trigger is doing a recalculation of database and VM parameters to have the correct setup for good performance. Because when you start with a Postgres or EDB from scratch with a default installation, it will probably not fit your performance criteria, but it's possible. So you can see we also decided to have a one-to-one setup, not license-driven architecture, technical architecture. So for each database, we build a separate VM. So we built up to 350 databases. High availability solution is always there, and we built it with Enterprise Failover Manager. We also built day 2 operations. This means all that we need in the daily operation, enlargement of RAM, CPU, and so on. We can do this via click on the VM machine. Short overview about the components, only that you have the list where we started. So it's VMware 6, it's Red Hat 7.8. We started with 7.6. This is essential. I can say it in the later slide. EDB is version 10. We started in the project with 10.6. Now we are on 10.12. Enterprise Failover Manager from 3.4 is currently in the rollout to 3.9. Our cloud order slide. You can see a lot of list buttons, and they are filled with official values for customers, service definition, deployment stage, life cycle, and so on. The sizes, you can see it here, left, down here, are in the GUI free and can be set at willing, but we define t-shirt sizes for the machines to have a standardized VM. In the project, we found also some special applications that need extra code pages different from UTF-8. So we implemented also pull down to set the character set. Currently, we have 3 sets in the list. With the other parameters on the screen, the automatism, build machine name, database name, and all this together, the customer name, the billing, and so on. At the end, the database is created with the VM, fully, completely with all OS users, database users, necessary database roles, also the connection to the monitoring system, the backup system, and all this is done. The machine is ready for use. The really nice point here is when you set this HA feature here, it will build a complete high availability cluster. So it needs the information about the witness. So we built the machine before, and then the automatism is running. Build a primary VM with database primary, build a standby VM with the standby database, connect them all together, and we have a running EDB cluster ready for production. Problems and solution, short slide, a lot of points we can talk about. This list is really an example for the major parts you should invest your time to evaluate with the teams and how to implement it in detail. Otherwise, you will have problems in the automation. The users find out the right concept for namings. Which users do you need on database side, on OS, on Active Directory? Which users must belong to which Active Directory role? And we have a special database security concept for roles. And think about it, build it via scripts, and you can automate it from the cloud. Documentation, for sure, you have to read the documentation from the database side, but I can warn you a little bit, not all that you need is in the documentation. There's really potential in the documentation. It's good, all is in, but so more practical information, how you set up a mid-range machine or a high throughput machine that's missing, and you have to find it out. Kernel parameters and limits are really essential. So do a good testing of your application and find out which tuning do you need. As I said, the default is not good enough and will definitely not a fast database. Check your groups of sizes that you need, the t-shirt sizes of the databases, and be careful with the limits. The postmaster process owns all the other processes. So check your Unix limits to your database user, the open files and the U limits especially. And because additionally the EDB concept or the Postgres concept is completely different from DB2 or Oracle. Each object in the database is at least 3 files on the Linux for table, for index, for handling. And this number can be really big with thousands of estimated database sessions. The Postgres SQL-conf is really the central parameter file up to version 10. So in version 12, it's a little bit different, but for now we have version 10. The EFM and the network, I have an extra slide there. Check your networks that have to connect to the database and also how much throughput you have available. And I can show you on the next slide. Really example, the init parameter checksum. It's only one, as I said in the beginning in chapter 5, you will find a summary of parameters that we are using. But the checksum is really essential parameter. When you create our databases with the initDB created with the checksum parameter, this is really very essential. When you want to use checksum on the Linux side for block corruptions, XFS problems, or others, you need this parameter set, and unfortunately, it is not set in the default. The network is a short overview about the communication in the EFM cluster setup. The picture on the right side, it's principal default. You have a master database. You have a streaming replica, standby. You have a witness, that's the observer node for the primary and standby communication. And you have a client that will connect to this via a virtual IP. From Oracle, you probably know that you can have the standby cluster traffic completely isolated from the user traffic to the application, because the standby traffic on a high-load databases can be really huge. This is normally done with virtual interfaces or physical cards. With Postgres and also EDB, this is not possible for version 10. I haven't tested it on version 12 now. We tried several ways and followed a lot of documentation to implement it, but nothing works. So far, it's no problem in our setup, but that you have to know and to monitor your interfaces. Probably there's something new in version 12, but up to version 10, it is what it is. So you can find the documentation, parameters for virtual IP and what I have listed on the slide, but it is not working. The complete traffic is going via the standard interface for application and for the streaming. The current status of the deployment. Short slide, few words. The deployment is now much faster. The 20-hour on the slide for the deployment is not to overload the picture. As it said, it was days up to 2 weeks for a high availability cluster. The deployment time for the complete setup, including VM databases, all users, backup infrastructure, monitoring setup and configuration, is now done within 40 to 60 minutes. For a HA cluster, about 60 to 90 minutes. And that is really great. So now we can go really agile, react in hours. From performance perspective, we are now 10 to 20% faster in comparison to the old DB2 database environment. And this is a very good indicator for us, because the old code was optimized for DB2 over 10 years. And for EDB Postgres, we have now 1 year. But you need the right parameter set, and as I said, you can find a parameter set as a good starting point in the reference. Last section, chapter 4, the status, the lessons learned, and the conclusion of the project. The current situation, we have 40 services migrated and delivered in time. We had one problem that was really essential and hard to solve. It was the XFS corruption bug, dependent on the starting Red Hat version and database version in the migration phase, shortly before cutover and during load phase of the content manager databases. We learned a lot about how EDB is working with the Linux, but with really good and committed support, and really from the technical team from EDB, we managed to get it done and implemented in the meantime a pre-warning system in the monitoring. And now we are really fine. The monitoring system is changed to this from Aloytech, and as a service monitoring, and we use also PEM, the Postgres Enterprise Manager for database special monitoring. We are live since December 2019. Few problems from database layer and hardly any critical failure in 1 year of operation. The databases are in the meantime 4.5 to 4.8 terabyte with 128 gigabyte RAM, and they are running without any problem. So EDB is really suitably tested for large and business critical environments. With a fully automated provisioning of VM and database from the private cloud, single and high availability, it's really essential for us. I said it, day 2 operations for online extensions, they are possible in minutes. including a recalculation of Linux and the performance values when you change something on CPU. The UTF-8 character conversion in the database is also done in the database without any bigger problems, but for sure you have to check your application layer and your client settings. The lessons learned, do not underestimate the emotional component. Probably you know the graph on the right side from the change management processes, and we have seen exactly this graph in the team. It is hard for people that have done 20 years and more with DB2 and Oracle in the first 5 phases. But now, in the meantime, they have really fun with Postgres and EnterpriseDB. Really essential, do a complete review of your application. You have to understand how it is working, which code you have. Really testing. Start with a POC, not only with paperwork. EnterpriseDB is really ready for high-load databases and business-critical environments. And think about automation. It's really good, doable. I have to hurry up and come to a conclusion. So, conclusion of the project, we have provisioning hours, version and provisioning weeks. We can do now batch quantities of deployments using workflow. So when a new customer come in and I need 100 machines, I fill in a small batch file, give it to the workflow, and they are done in 1 day. No reworking necessary after provisioning. They are ready for production when they are built. We facilitate the daily business by day 2 operations, root access, enlargement of resources, and performance by precisely calculated parameters is really good. With the one-to-one setup, we have really smooth operation and very rare incidents on the platform. Currently working for other database systems in the same manner of the private cloud, and permanent expansion of our cloud service is planned. So currently is in project to provide EnterpriseDB in DMZ on secure Linux, and also the migration to version 12 is in work. So I'm on the end, and now I'm open for questions and feedback from your side. Hope you enjoyed the lesson.